Welcome back, everyone. Today we're going to be checking out the January 2024 Earth Science Regents. So I'm going to go through the whole thing. You can feel free to take notes if you want as you go. You can watch me do it. You can do it on your own as well, and then just pause and I'll go over every question eventually. So however you want to tackle this. All right, here we go. We're starting on page 1. And we are on this question here. It says the diagram below represents the moon at one position in its orbit around the Earth. The numbers represent locations on the Earth's surface. So we see a 1, 2, 3, and 4. Which diagram would the high tide be occurring when the moon is at the location shown in the diagram? Okay, the moon's here and the Earth is here, right? So the tides are going to be happening on planet Earth. So that means the high tide is going to be at 1 because it's in line with the moon. It would also be here. So but that's not an option. So number 1 is the one we're going to go with. All right. Going on to question 2. Cosmic microwave background radiation provides evidence of. This is just a rote memory question. The Big Bang is going to be the answer here. The other piece of evidence would be redshift. Number 3. How many degrees does Earth travel in its orbit in 6 months? Well, 360 degrees would be a full year. So 6 months is going to be divided by 2. So that would be 180 degrees. All right, number 4. The constellation Orion is visible in New York State in the night sky during the winter, but is not visible in the summer. Why? So anything to do with constellations changing is going to be seasonal, which means that's going to be the Earth revolving around the sun. So the answer here is going to be 2. Number 5. This is a Foucault pendulum. So since it's a Foucault pendulum, I already know the answer is going to be the Earth's rotation. So that's just from memory. So that would be number 1, spinning on its axis right there. Number 6, the diagram below represents a flagpole and its shadow at New York State at solar noon. So keywords there, New York State at solar noon. That means the sun is at its highest point and it's in the south. So that means if the sun's in the south, you got to imagine it over here. This would be the opposite direction, the shadow of wherever the sun is. So this would have to be north, 2. Which term best describes the curving of the Earth's planetary winds? Again, this is rote, so you just had to memorize it. That's the Coriolis effect. Number 8, which landmass has at least one location where the sun would be directly overhead at solar noon in some time? Okay, so the only locations that you can ever have the sun directly overhead is the Tropic of Cancer, so 23.5 degrees north, to the Tropic of Capricorn, 23.5 degrees south. So I need a place there, and obviously you probably don't have that memorized, so you would go to the reference tables here, and we would go down to page 4 or 5 here, and we can see anywhere from 23.5 degrees north is going to be here, and 23.5 degrees south is going to be there, except my line is terrible. So it looks like Australia would be good. Let's go see if that's a choice. So, yes. The other 3, so if you're on the regions, check the other 3 to make sure they're not in that zone. Number 9, what is the primary source of energy that causes all weather on the Earth? So it's going to be the sun. So we need to have something to do with the sun, which is going to be here, incoming solar radiation. Number 10, we have a relative humidity and dew point question. So we're going to go to our chart. We're going to get this all set up so that way we can check it out as we go. All right, here we go. We're here. And the dry bulb temperature is 18. The wet bulb temperature is 8. So we're going to subtract that first because we need the difference between the wet bulb and the dry bulb. So that's going to be 10 degrees Celsius difference. Dry bulb 18, and they want us to get a dew point. So we got to go to 18 and 10 on this dew point chart. So 18 right here, 10 is right here, and we're going to meet. So we're looking at -5 for that one, and we hope that's a choice, and it is. Number 11, the polar front jet stream in the Earth's atmosphere is located in where? So this is on the reference table. You could get this if you don't have it memorized. You could memorize that the jet stream is pretty much between the troposphere and the stratosphere, but we can go here and just be sure. Right here, see? Polar front jet stream right there. There's the tropopause. So it's pretty much the upper troposphere. It's like right before the tropopause. So we're going to pick number 1. All right, we're moving on. Number 12, which two weather symbols represent severe weather? So we're going to go to the reference table, and we're going to go to our chart with the weather stations, which is right here. And severe weather, we want thunderstorms and the tornadoes over here. So those are going to be the two that we're going to pick, which would be 3. 13, compared to the average temperature at the stratopause, what's the temperature at the mesopause? Okay, so we have to get the stratopause temperature and the mesopause temperature, and then we're going to subtract. So we're going to go to here. Stratopause temperatures right here is 0. Mesopause is -90. Stratopause 0. Mesopause -90. So it's going to be, the mesopause is 90 Celsius lower, 3. Which gas is important because it protects us from harmful ultraviolet radiation? The answer is ozone, 2. It's in the stratosphere. This is, again, rote, so you just have to memorize it. 15, equal areas of which surface absorb the most insolation? So this is going to be dark and rough surfaces. So dark, automatically, sandy beach is out, calm lake is out, snow is out. This is going to be the crushed basalt. That's dark and rough. 4. Many periods of global warming have occurred during the last 100,000 years. Why? So they want to know what's the cause in global temperatures rising. So that's going to be something to do with carbon dioxide. So that's a greenhouse gas. So number 3 is going to be it. Remember your 3 greenhouse gases: CO2, methane, water vapor. Okay, going on. 17. The diagram below represents 4 landscapes. They have the same soil characteristics but different combinations of vegetations and slope. If these landscapes receive equal amounts of precipitation, which one will have the most runoff? So runoff, I like to think of it as flooding. Okay, so runoff, so things that are going to prevent flooding is flat. So we don't want flat, and we don't want vegetation. Vegetation's like trees, and that's going to absorb the water. So that's out, that's flat. So 2 is going to make the most runoff. It's got like no trees, and it's on a slant. 18, what type of front is this? Okay, the first thing I see is a cold, a cool, and a warm. So there's 3 air masses. There's only one type of front with 3 air masses, and it's occluded. So the 3 and 4 are out. And you could see the cold air mass is overtaking the cool air mass over here, which is going to launch this warm up. So this is going to be a cold front coming in, taking over the warm front there, number 1. 19, we got a nice fossil here. So we're going to find that fossil on our geologic timescale. Right when you see a fossil shape like that, look, there it is. Z. Muscosporifer. I can't even read that right now. Muscosporifer. Don't mind my pronunciation on that guy. And then what is this? So obviously the name of it's not there. So what we're going to do is we're going to find Z on this bar. And look, Z is right here. And it's on the bar that says brachiopods. So that's going to be a brachiopod. We're going to circle that one. All right, cool. Number 20, we got debris. There's at the same time as the extinction of ammonoids. Okay, we need to find when that was. So we're going to go here to our reference table, find extinction of ammonoids, and right here. So we know that's like 65.5 million years ago. Okay, so now we're going to see what our choices are here. Which one would have above and below that time? So we need to find the one that's under 65.5. So the middle 65.5. So which 2 are surrounding that on here? So look, 65.5. So it's between the Cretaceous and Paleogene. Is that a choice? Yep, 4. Why is volcanic ash a good geologic time marker? So this is going to be a good like index fossil. So it's going to be 2 things: a large area or a short time. Okay, so we need one of those. So there's long periods of time. No. Large area. Yes. 2. There you go. All right, we got a sequence of events here. So essentially what ended up happening here, the sandstone was deposited first, then the limestone, then this intrusion came in right there, and then the shale came in on top of that, because you could see the contact metamorphism dashes right here are not here, which means that the intrusion happened third, and then this layer on top was deposited. So now we can look. So the igneous rock, which is this, that would be older than all of them? No. Younger than all of them? No. Younger than older than the shale, but younger than the sandstone and limestone. That's correct. And how do you know which layer is which? You go to the reference table, and you could go to the rocks, and you could see the dots are sandstone. Then we got the limestone there. Our shale is the dashes. That's how you know. 23. For which New York State location is the table are both the geologic age of the rock and the dominant type of surface bedrock correct? Okay, so we're going to go to New York State. And that would be page 3. Go here, rotate that. Okay, so now we're going to find these spots, and we're going to match the correct things on the bottom here for the symbols. So watch this. So Finger Lakes, they're saying it's Devonian. So let's see, Finger Lakes are here. Devonian, so there's dots. Dots, that's correct, and that's limestone, shale, sandstone. Is that what they put? No, they put gneisses and marble, so that's wrong. So that one's probably out. Mount Marcy, let's check it. So Mount Marcy's here. So it looks like little sprinkles. Let's find the sprinkles right here. Middle Proterozoic, good. And then it's anthracitic rocks or intensely metamorphosized rocks. So let's check that out. Middle Proterozoic, yes. And then they put sedimentary. That's out. All right, we'll check Syracuse. Find Syracuse, which is right here. It's the lines going vertically, so that's right here. Silurian, which is limestone, shale, sandstone. It's not Cambrian, so that's out. All right, so now hopefully this one's right. Watertown, right here. So there's diagonal right there. Look, Ordovician, we're good so far. Limestone, shale, sandstone. Let's see. Yes, great. Unfortunately, that took a long time because the last one was right. 24, which table shows the correct characteristics when they reach liquid material? We got P waves and S waves. Okay, so P waves can travel through solids and liquids. S waves, S can only travel through solids. So we have to see which one is right. Ability to travel through liquid. So we don't want the S wave to go through liquid. So this is right, and P wave can't. So this one's right. This is wrong. This is wrong. They're both the same. And then this is saying P wave can't go through liquid. That's wrong. So one's right. 25. Okay, we have a nice little earthquake question here. The first S wave in an earthquake took 10 minutes and 40 seconds to travel to a seismic station. Okay, what's the distance from this seismic station, and how much time did it take the P wave to go there? Okay, so we're going to go to our earthquake chart. Great. Okay, here we go. 10 minutes and 40 seconds, which is right here. So we're going to go to the line. Right there. So we got our distance, 3,200 kilometers. So 3 and 4 are out. And then how much time did it take a P wave to travel at that time? So we're going to go to that spot right here. P wave at that time, 6 minutes. Got it. 26. Which two hotspots are located on the same plate? Okay, we're going to go to page 5. Our tectonic plates right here. And we're going to find two that are on the same. So I just saw it instantaneously. It looks like Canary and St. Helena, because this is the African plate right here. Right? Canary and St. Helena are both on the African plate. But obviously, when you're on the test, check them all just in case, but that one's good for 4. Long Island is which landscape region? Okay, so landscape region is going to be here. And we're going to find Long Island, which is down here. If you didn't know where Long Island was, you can go to page 3, and it says Long Island right here. So you go to that exact spot on this map, and you can see it's in the Atlantic coastal plain, and hopefully that's an answer, and it is number 4. 28. The data table below classifies 3 types of sand based on their particle diameters in centimeters. Okay. Which stream velocity would cause medium and coarse sand to settle to the bottom of the stream, while fine sand continues to move downstream? So we want to be able to move medium and coarse, which is 0.04 and 0.1, while fine sand continues to move. We want to actually see the fine sand can move, so it's strong enough to move this, but we want to drop these. Okay, so we're going to go to our chart here. Here we are. So now we have to get these numbers. We want to move 0.01, so here's our 0.01 right here. So we want to move this, but we can't move 0.04 or 0.1. So we can't move this or this. So we need it to be essentially under this in speed. We can't have it above, these go up by ones in this section, so we pretty much can't have it above like 2 centimeters per second. So this looks like it's going to be right. 1, let's just double check. 0.2 is not going to be able to move that. So that's the answer. 1. 29. What is the primary reason that water-filled cracks in rocks widen in the winter? It's because water expands when it freezes. So when water freezes, it gets bigger and it makes the cracks widen. This is called frost action. That's a type of physical weathering. All right, number 30. We got this sandblasted landscape here. Okay. Which type of climate is going to be good for this? So this automatically looks like a desert, right? It's in Utah. This looks like there's no vegetation here. So arid means dry. So it's definitely going to be arid. And then in the desert, there's wind. There's no water in the desert, so that's out. So it's 4. Kettle lakes are formed when blocks of ice are partially buried by sediments and melt on what? So in this case, for a glacier, a floodplain is only for a river, a sand dunes for the desert, and then a barrier island is like a beach area, so an outwash plain is good for a glacier, so that's 2. Which mineral resource is used in making bricks and jewelry? So for this one, we're going to go to page 16. And we're going to find bricks and jewelry. Let's see, jewelry. Okay, haven't seen bricks yet. Oh, there's bricks. Look, bricks and jewelry. Furnace bricks and jewelry. It's olivine. 4. All right, here we go. 33. We got this outcrop, and this automatically looks like some distortion happening. This was like some plate movement, maybe. They were like going like this and converging. So this is going to be some type of crustal movement. 3. Number 34, we got some watersheds. Identify 4 of them. Oh, it says identify 4 of these watersheds. Great. A, B, C, D. The Genesee River is in which one? So we're going to go to our page 3 on the reference table. And we're going to find the Genesee River. Look, it's right here. And we're going to go to that exact spot on the page. And it looks like... C? Looks like about there to me. Let's see. Yeah, it looks like about C. I'm going to go with C. It's hard to do this on a computer screen and see it. All right, 35. We have the arrows indicating a stream. So the first thing you should be like, okay, this is the outside of the curve. This is the inside. So we're fastest here with the most erosion at A. Okay, amount of erosion. So A, we want the most. So this is going to be this one, and it's going to lower as you go. So this is going to be 1. All right, we have which mineral has a chemical composition most similar to chert? Okay, so we're going to go and try to find that in this reading because we don't know what chert is, right? It's not in the reference table, so we're going to look here. Let's see. It's red. Most often contains a lot of SiO2. So it's something to do, we want SiO2. And if you go on the reference table and you go down to here and you look for SiO2, it's going to contain a lot of quartz. So there you go. 2. Make sure you're reading the readings. 37. The first organism that developed the ability to undergo photosynthesis and produce atmospheric oxygen were what? Okay, so this one is on the geologic timescale. There it is, oceanic oxygen produced by cyanobacteria. So it's going to be 4. That came before all the other 3. Which one correctly identifies the composition of the red and tan layers? Okay, so we're going to sort of see here. Iron is the red color, it says. So we need the one with iron to be the red. Okay, so if iron's the red, and it's saying the red's on the top, we want the iron on the top. So chert's not on the top, iron's not on the bottom, and iron's not on the bottom. So this is going to be the answer, 1. 39, we got a moon phase. Oh, 39 through 42 are on this moon phase chart. Okay. During the month of April 2024, there will be a total solar eclipse for large portions of New York State. On which day in April will the solar eclipse occur? Okay, so solar eclipse, you're going to want a new moon. So it's going to be that. April 8th, 2024, 2. Hopefully you're able to see it. Which diagram below represents the position of the moon on April 12th? So we're going to go to April 12th right here. So that's going to be a waxing crescent. So we want to, which is going to be right here at 3, because if you cut this here and you're standing from the Earth, the right side is going to be lit up. So it's going to be 3. 41. The same side of the moon is always visible to an observer on the Earth because the moon has a period of rotation equal to the period of its revolution. So not the Earth. It's the moon has an period of rotation equal to its period of revolution. So if you don't have that memorized, you can go down here and you could check it out. Look, Earth's moon here. Period of rotation is equal to its period of revolution. Compared to the density of terrestrial and Jovian planets, the density of the moon is, okay, we're on the same chart. The moon's density is 3.3. Terrestrial planets are more, that's Mercury through Mars, and then Jupiter through Neptune are less. So it's like right in the middle. So it's greater than, less than both, no. Greater than both, no. Less than terrestrial, but greater than Jovian, yes, 3. All right, we got a weather map with some isobars. Locations W and X are within which type of air masses? Okay, W is here, X is here, right? So this is behind the warm front, so this is warm. W is behind the cold front, so this is cold. Okay, so this is probably, that means this is MT and this is CP. CP comes from Canada, MT comes up from the Gulf of Mexico. So let's see if we can find that. We want X to be an MT. So that one's wrong. That's wrong. X is in MT. That's right. So that's the only one. Which weather station has approximate pressure of 29.65? Okay, so we got to look at our weather stations, and they're on these isobars. So this one's 1012. Besides doing this, I think we should just go to this. This is probably the fastest way. Go here and find 29.65, which is right here. So we want it to be about 1004. So it's going to be this one. 1004 is going to be the X. Prevailing winds will cause this low pressure system to most likely move where? Everything in the United States goes northeast. That's 1. All right, we got some celestial sphere diagrams, 4 different locations. Okay. Which location will the longest shadow be observed? So you want the sun lowest to get the longest shadow. So we want the sun to be low, so it's going to be this one here, Arctic Circle. 3 months after the date indicated in the diagrams, sunrise in New York State will occur where? So we got to see, this is June 21st. So if you go 3 months after that is going to be September 21st about, which is an equinox, so it rises directly east. 1. All right, we got radioactive decay. Which percentage of this isotope remains after 3 half-lives? So just use, look, here's your radioactive isotope. Here's 3 half-lives, so it's like a little bit more than 10. So it's going to be 2. What's the disintegration product of this isotope? So we have to find out which one they used. So they used carbon-14. You go to the reference table, page 1. Carbon-14 changes to nitrogen-14, so it's going to be 3. Carbon-14 could be used to determine the ages of both what? So it's got to be something that was alive. So, like new, recent, alive. So probably 3. Trilobites are so old, and so are dinosaur fossils. So you want things that are like recently, like humans and things like that. So if you're wondering how you would know that, you would just go on the geologic timescale, which is here, and you could sort of see, okay, humans and mastodons, they're up here. That's very recent. The dinosaurs are all down here, and trilobites are like way down here. All right, part B. Base your answers to the following questions on the picture below. This is a dwarf planet, and it says there's a table that includes data about it, so we'll see what's going on here. So it says it's the largest object in the asteroid belt, located between Mars and Jupiter, and it's smaller than Pluto. It's a dwarf planet, has a very thin atmosphere containing water vapor. Okay, here's some data about it. Great. Identify the planet in our solar system that is an equatorial diameter 5 times the equatorial diameter of Sirius. So we're going to need a calculator for this one, and we're going to get our equatorial diameter here. So 952, and we're going to multiply that by 5. I have a calculator in front of me that you can't see, so we're looking for something that's 4,760 kilometers. So we're now going to go to our chart here, and we're going to try to find 4,700, which is like really close to here. So Mercury is going to be our top answer here. So we're going to go to our answer booklet, and 51 is going to be Mercury. All right, 52. I see that it's in millions of kilometers, so we're going to take note of that. One possible distance from Sirius from the Sun in million kilometers. So it says it's between Mars and Jupiter, right? So we're going to find Mars. So that's 227.9 from the Sun, and then Jupiter is 778. So any number in between that is going to be acceptable. So I'll just put 500. All right. 53. Identify the planet in our solar system with an orbital eccentricity closest to Ceres. Okay, this is 0.079, so we're looking for eccentricity here, 0.0779, so it's kind of close to this one. I guess Mars is the closest. None of the other ones are close to 79, so we're going to go with Mars. Okay, 54. Identify how many circular surface features shown in the photograph. Oh, identify the many features that what they are. Okay, those are craters. And how are they formed? They're formed from impacts. So any space impacts, like little rocks or something like that that are hitting it from space. So we could say craters. And we could just say like impacts from space objects, and that should cover all the possible things that we could write for that. All right, 55. We have, looks like time zones here. Okay, determine the time of day at Atlanta and time of day at Los Angeles when it's 1 p.m. at Rochester. Okay, so this whole shaded area is 1 p.m. As you go west, time will get less by an hour. So this is 12 p.m., this is 11 a.m., and this is 10 a.m. So now what does it want us to tell? It wants us to do Atlanta and Los Angeles. Atlanta is here, so that's the same time zone as Rochester, so that's going to be 1 p.m. And then Los Angeles is going to be over here, that's 10 a.m. Okay. Cool. 56. Identify the city shown where an observer would view Polaris closest to the horizon. So Polaris is going to be equal to the latitude of the observer. So if it's a high latitude, Polaris is high up, but we want it closer to the horizon, so we want it closer to 0. So we want to pick pretty much the lowest spot. So Austin's going to be our best bet there. So Austin. 57. It's an epoch. So that's automatically, just by the booklet, I know I'm going to be going to here. My epochs. Alright, let's see what it's got. Alright, so we got a reading. Things to take out of this. There's a sea, 5 North American Great Lakes. It formed 5.5 million years ago. Let's see what the question is. What's the name of the epoch when it formed? So 5.5 million years ago, we're going to go here. 5.5 would be here, so it's the Miocene. So we'll get that one out of the way. Put that in our answer booklet. Alright, this one is kilometers cubed per year. We'll see what they ask about that. The nearest tenth, the rate of change in the volume of the sea per year in the 40 years from 1960 to 2000. Okay, so we know it's going to be change in value over time. The time's going to be 40 years. So we need to know how much the volume changed. So hopefully it says that. 1960 to 2000. Here we go. 1960 to 2000. Here's our volume. So we're going to do 1064 minus 400. 664 it changed by. So we're going to do 664 divided by 40. And that's going to give us 16.6 for that answer. Okay, 59. One human activity that led to the decrease in size of the sea, and describe one effect of this decrease on the environment. So let's see. In the 1960s, government officials have been diverting most of the river for farming. The size of the lake has dramatically decreased. It dried up. Fisheries and communities dependent on them collapsed. The increasing salty water became polluted with fertilizer and pesticides. Blowing dust, contaminated agricultural chemicals became a health hazard. And the ground is now unusable for farming. That's not good. So let's see. One human activity that led to the decrease in size of the sea. So it looks like farming. Diverting most of the river for farming. So we're going to write farming. And we can write literally anything that it said, but I'm going to write polluting just to be vague, which is always good on this. Alright, number 60. State one effect that the reduced size of the sea had on summertime air temperatures and the amount of precipitation. So seas right here, okay, if you're close to the sea, you're going to get cooler temperatures and more rain. So if there's less of a sea, the sea size has decreased, you're going to get warmer temperatures and less rain. So we're going to say the air temperature would increase and precipitation would go down. Number 61. Identify the Great Lake that has a surface area and volume of water most similar to the surface area and volume of water of the Aral Sea in 2000. So let's see. So volume is 400, so the closest one here is Lake Erie. So I was just reading the table. Alright, 62. Moving on. The garden pond owner has to add water to the pond on a regular basis. Explain why the water surface level would naturally decrease if the owner did not perform this task. So we want, how is water going to get removed? Right? So a naturally occurring process is going to be evaporation on that one. So 62, evaporation. All right, 63. Here we go. What would happen to the water if if the liner was removed? So if there was no liner here, that's the plastic liner here, the water would absorb into the soil. That's what would happen. So we'll say water would infiltrate into the soil. That would be bad because then there would be no water left. I'd be refilling it all the time. 64. In your answer booklet, circle the surface temperature and luminosity of Percad. That seems to be right here. Compared to the luminosity of the sun. Okay, so we need to go on our reference table and go to page 15. Okay, the sun is 1 luminosity and Like, looks like 5,800 surface temperature. So perk adds way more luminosity and higher surface temperature. So it's going to be, both of them should be higher. Hotter and greater luminous. Okay, next one. List Kochab, Polaris, and the universe in order by their age. So universe is going to be the oldest, automatically. And then Kochab is going to be this, and then Polaris is that. So it should go from oldest to youngest, so it should go universe, Kochab, Polaris. All right, 66. We have a beautiful stratigraphy diagram here. Okay, great. Let's see. State the name of the sedimentary rock layer that was the last to form before the unconformity XY. So let's see. Unconformity XY is here. So before that, it's going to be this. So we need to go on our reference table and find which sedimentary rock that is, which is going to be on the sedimentary rock chart, which is page 7. Right here, and it's going to be this one, Breccia. Alright, going on, 67. Describe the rate of cooling of the magma that formed rock unit D. Okay, what's rock unit D? So that's going to be the sprinkle coordinates. Oh, intrusive igneous rock. Intrusive. So intrusive takes very long to cool. Extrusive is very short to cool. So this would be very long cooling rate. That's literally all you would have to say. You don't have to say anything more specific than that. You could say slow. That'd be fine too. 68. State the diameter in centimeters of the largest particle size that's possibly found in the sedimentary rock represented by B. Okay, B, this is sandstone. So we're going to go to sandstone right here, and look, it's 0.006 to 0.2, so 0.2 is the biggest. Okay, going on. Oh, we got a graph. Let's see what we have to do. On the map, plot the 5 locations of the Hurricane Michael, center of Hurricane Michael, latitude and longitude in table 1, connect them with a line. Okay, here we go. 1986. 19 is here, 86 is here. 1. This is a fun question. 21.5, 85. 21.5, 85. You're going to be more perfect than me because I'm on a computer and it's hard to do it. 25.5, 86.5. 25.5, 86.5. 86.5. There. Okay. 30 and 85.5. 30 north. 85.5, which is right there. And 35.5 and 80. 35.5 and 80, which is right here. Okay, my line that's about to connect these is going to be awful. So yours is going to be straight on the regents. You know, you would do it as straight as you could. So you should have got something like that. Okay, beautiful. So now we're going to go and see what the next question is. Based on the maximum sustained winds, identify the category that the Hurricane Michael was when it made landfall. Okay, so we got to get here. So on our chart, it made landfall right there at that 4th spot, so at 30 degrees north. So here, so the maximum is 160 miles an hour wind, so that's going to be category 5. Ouch. That's going to be a really, really, really powerful storm. All right, 71. Describe the relationship between air pressure and maximum sustained wind. So what you have to know for this one, the higher the air pressure, the better the weather. So as air pressure increases, wind speed would go down. So this is an inverse relationship. Or otherwise, you could say as the air pressure goes down, wind speed goes up. All right, going on to 72. What do we got? On the map in your answer booklet, draw the 30 and 40 meter contour lines. Extend both to the edge of the map. All right, again, I'm going to try my best with this digital pen, and we'll see how we go. Okay, we're going to do 30 and 40. So here's 30. Make sure we're hitting the dots. 30, 30, right there. I'm going to go the other way. 30, 30. Okay, then 40 would be here. Through here, here, up here. Like that, and then right there, and then we gotta come down here. Should be like that. I think that looks good. Beautiful. All right, state a possible elevation of point A. Let's see, point A, where are you? Here. So it looks like we're going by tens down here, so this is 60, so it's anywhere from 61 to 69, so I'll put 65. Okay, 74 and 75. There is the intertropical convergence zone, is a belt of low pressure that circles the Earth where the planetary winds converge. Okay, it's saying there's a certain amount of precipitation during those months. Okay, compare the amount of precipitation that occurs at location X in July to the amount that occurs in the same location in January. Okay, so where's X? So we gotta go here, and that would be here. So you could see there's more precipitation in January than there is in July. That's all you have to say. Yep, because there is more precip in January than July. 75, determine the approximate distance north of the equator where the greatest amount of precipitation occurs in Africa during July. Okay, so we're going to go to July. Okay, most precipitation we want here. So it's going to be like here, which is like 5 degrees north. So what do we have to do here? Approximate distance north. So maybe like, I don't know, 6 or 7 degrees north maybe. So then we're going to have to, if it's there, they want us to find the distance from here to here by using the scale here. So if you were to measure that, I can't do that on the computer, I would probably do around 500-ish, but anywhere from 400 to 900 would be totally fine. So we'll just put 500. All right, another graph. 5 earthquakes. We have to draw the plots again and then connect them. Do not extend your line beyond the given data. So 0, 10 is the first one. So these are going up by tens. 0. 0 distance from location A, depth of 10. Okay, so it's a depth. So 0, 10. Okay, next. 100, depth of 35. 100, 5, 10, no. 100, 10, 20, 30, 5. Again, your dots will be better than mine. 225, 80. 225. And then 80 depth. Right there. 310, 170. 310. 170 is right there. Stray mark. And then lastly, 335. Which is somewhere in there. I forgot the number, so I'm going to 235. 235, which is 10, 20, 35, which is right here. Okay, and then it wants us to connect those with a straight line, and mine's going to be absolute terrible. So just you know, ignore my straight lines that are not straight lines, please. Yours are going to be pretty straight. There we go. Okay. State the names of the tectonic plates on each side of the boundary of location A. So this is Sumatra. Indian Ocean is here, so we need to find this exact spot on page 5. Okay, Indian Ocean, Sumatra. Go back to my picture to see how you would see this. Oh, it's directly under India to the right. So it's going to be like here. Okay. So now we're going to go A to B. Is that what I wanted? The outside of that boundary. So it's going to be this side, which is the Indian-Australian plate, versus this side, which is the Eurasian plate. Indian, Australian, and Eurasian. Okay. Going on. What is the name of the layer in the mantle with the deepest earthquake shown in the table occurred? So 235 kilometers, and then we're going to go to page 10. And we're going to go down to 235 kilometers. Depth. So this is 1,000, so we're like right here. And we're going to go up. It's the asthenosphere. Okay, 79. On September 28, 2018, a tsunami warning was issued to the people only a few minutes before the wave came to shore. One action they should have taken. So the first thing they want to do is evacuate. So they could either evacuate or they can get to high ground. So if they only have a couple minutes, I would say either one of those is good, depending on where they were. We'll put get to high ground. That would be good. All right, we got this nice little map here. Dark line shows the southernmost advance of the last continental ice sheet in North America, so the ice sheet came down to there. And there's times, it said. Oh, no times, okay, cool. The glacial moraines that form much of Long Island mark the farthest advance. Describe the arrangement of rock particles in moraines. Okay. Glacial moraines are unsorted. Number 81. Old river valleys in central New York State were eroded by glacial ice, forming the Finger Lakes. Describe the cross-sectional shape of the original stream cutout valleys. Okay, describe the cross-sectional shape of the valleys that were carved by glacial ice. So stream valleys versus glacial valleys. Stream valleys are V's, glacial valleys are U's. That's what they want you to know. So this is going to be V-shaped. And that's a U shape. I tried to make my V and U look separate, but that's what you want to write. Okay. In some places, grooves and parallel scratches are evidence that the ice sheet moved. Explain how the grooves and scratches were produced by the glacial movement. So there's going to be abrasion. So essentially there's like this material locked in the ice, and the rocks are essentially dragged over the surface rock, cutting out those grooves. But abrasion is the process. You could also say like the rocks that are lodged into the bottom of the glacier scraped it. Anything like that's good. All right, 83. Compared to the texture of basalt, how is the texture of granite different? Okay, so we could just use our reference table for this. Basalt and granite are going to be up here. Okay, here. Basalt here. Texture is fine. Granite texture is coarse. That's all you had to say. Granite is coarse. And you could also say basalt is fine. Both good. One possible material that was most likely buried or compacted during the process of rock formation represented by C that resulted in formation of coal. Let's just look. So C, so we need to find coal, so that's going to be here. So if you look at bituminous coal, it's right here. Compacted plant remains is what we're looking for. Plant remains. All right, last question. State the name of one rock that could be represented by D. So we're here. So it says crystals. So this is going to be sedimentary first. Crystals from precipitation evaporation near the Earth's surface. And we're going to look here. Sedimentary, precipitation evaporates. So rock salt, rock gypsum, dolostone are your answers. I will write rock salt. All right, that was all 85 questions. Thanks so much for joining me. Hope that was fun. If you like this video and you want me to do more of these full regions videos, let me know. I can do more of them. And good luck studying. Talk to you later. Bye.